Hello everybody and welcome back to a brand new video. And in this video I will be covering problem D, that was empty graph from round 813. Also, like I said in the last video, I'm still recovering from a fever, so if my voice is a little awkward, sorry for that again. Yeah, so as that's out of the way, let's start with the problem. So in the problem, we have been given an array, right? So something like A1, A2, A3, so on up to AN, right? And we form a complete graph out of this, right? So we form a complete graph out of this. And what is a complete graph? A complete graph is a graph in which every two nodes have an edge, So for example, if we take any two nodes, let's say L and R from 1 to n, if we take any two nodes L and R from 1 to n, they will have an edge, right? And according to the question, the weight of the following edge will be how much? It will be minimum of AL plus 1, so on up to AR, right? So we will take all the nodes and we will form a complete graph. That is, we will form a complete graph with nodes from 1 to n, where every two nodes will have an edge, and the weight of the edges will be how much? For example, if we have two nodes L and R, then the weight of the edge will be minimum of AL plus 1, so on up to AR, right? So that's how we will form the graph, and that's how we will weight the edges. Along with this, we have been given a parameter k, right? That means we can change any k of these terms, right? That is, we can let's say change a1 to any integer value from 1 to 10 the power 9, right? So we can change any k values in the array into any value from 1 to 10 the power 9. And our mission is to maximize the diameter of the graph, complete graph, right? And we have to tell this maximum diameter, and we have to answer is equal to the maximum diameter, right? So that is what we want to report. So I hope the problem is clear, right? So we have been given an array. We form a complete graph out of the array, right? And we also have been given some k operations, right? That is, we can change any k elements in the array into any value from 1 to 10 the power 9. And we want to do so in such a way that the diameter of the graph is maximized, and we want to report this maximum diameter, right? So that's the problem. So how can we solve this? So now let's start with the solution. Also, going forward, I will call the minimum element of the array as a min, right? And I will say that it is present at some index min, right? So the very first observation that you need is that the diameter will always be less than equal to 2 times a min, right? So how can you say that? So if you think about any two nodes, let's say you think about nodes L and R, right? So there will be an edge between L and R, and the gap between L and R, the weight of the edge will be how much? The weight of the edge will be minimum of AL plus 1, so on till AR, right? And as the graph is complete, there will also be an edge between L and min. And similarly, there will also be an edge between R and min, right? And as min is the smallest element, right? So the weight of the edge from L to min will be how much? It will be a min, right? Similarly, the weight of the edge from R to min will be how much? It will be a min, right? So if you see the following path, the weight of the following path is how much? It is minimum of AL plus 1, so on up to AR. And if you see the falling path, the weight of the falling path is how much? It is 2 times min, right? So you can say the distance between L and R is how much? Minimum of 2 times min and minimum of AL plus 1, so on up to AR, right? So as you can see, there is a 2 times min term here and there is a minimum outside, right? So our gap between two nodes L and R will always be less than 2 times min, right? So our gap between two nodes will always be less than equal to 2 times min, right? So if weight between any two nodes is less than 2 times min, then our diameter will also be less than equal to 2 times min, right? That's obvious. That's one thing. And the second thing you can see is that there is also the falling factor, right? There is a factor minimum of AL plus 1 up to AR that is also contributing to our diameter, right? Because it is contributing to our gap and our gap will then contribute to our diameter, right? So if we can improve the min term and we can improve the following term, then we can improve the diameter in general, right? So if you think about the following term, right? So if you think about the following term, you can see here we have minimum of AL plus 1, so on up to AR, right? And there is a minimum outside, right? There is a minimum outside. So if you keep on adding terms here, it will keep on decreasing. Which is not helpful to us, right? So to maximize this as much as possible, it is helpful to reduce terms. Right? Or you can say just care about adjacent nodes. For example, just care about AL and AL plus 1, right? So if you just care about node L and L plus 1, then your expression will be how much? Your expression will be distance between L and L plus 1 is equal to how much? It is equal to minimum of 2 times min, comma minimum of AL comma AL plus 1, right? So as you can see here, now there are just 2 terms here, right? So it is more likely that the following term will be large now, right? So now there are just 2 terms here, right? So now it is more likely that the following term can be large, right? So now we have made some observations and now we will use this observation to solve the problem, right? So now we have found a formula that our diameter is equal to maximum of distance over all adjacent nodes. So you can just say your diameter is equal to maximum over for all I, right? For all I, minimum of 2 times min and minimum of AI and AI plus 1, right? So now we have a relation for our diameter. And now we want to maximize this diameter. So obviously if you want to maximize this diameter, the very first thing that you want to maximize is this A of min thing, and then we want to maximize this A of I and A of I plus 1 thing, right? So how can we go about this? So for this we can use binary search. So we will binary search over the maximum diameter that we can have, right? So let's say I want to check if my current diameter, let's call it my current diameter is, let's say, equal to mid. Now I want to check if my diameter mid is possible or not, right? Because in binary search, the very important function is the check function, in which you can check if your mid is viable or not, right? So now we want to check how we can check if our mid is a possible diameter or not. So how can we check that? So first of all, let's see the formula, right? So we have two terms. We have minimum of 2 times a-min and minimum of ai and ai plus 1, right? So we want to check if our mid is a possible diameter or not. So that means our 2 times a-min should be greater than equal to mid, right? That's the first case or first condition, that our 2 times a-min should be greater than equal to mid. So we will just iterate over all the elements. We have a1, a2, a3, so on up to an, right? We will just iterate over all the elements, and for whichever element 2 times ai is less than mid. If my 2 times ai is less than mid, then I will use an operation here. And set ai equal to 10 to the power 9 and set ai equal to 10 to the power 9, right? So that's the first condition, right? Because to have my diameter is equal to mid, my 2 times a-min should be greater than equal to mid, right? So I will just iterate over the whole array, and for every index I such that 2 times ai is less than mid, I will set my ai equal to 10 to the power 9, right? So now I have taken care of my following term. Now I just need to take care of my second term, right? So the second condition is that my minimum of ai comma ai plus 1 should be greater than equal to mid, right? That's the second thing. So there can be 3 cases now, right? Because after checking first condition, you have applied some operations here, right? You have applied some operations in the first condition, right? So you will have some leftover operations. So there are 3 cases here. So if your leftover operations is equal to 0, right? That means you have no choice, right? That means you cannot do anything. So for that case, you can just iterate over the whole array and just manually check if minimum of ai comma ai plus 1 is greater than equal to mid for any value or not, right? So if your leftover operation is equal to 0, just iterate over all values of I and check if for any I minimum of ai comma ai plus 1 is greater than equal to mid, right? Because you don't have any operations, right? You cannot do anything anymore. So your only choice is to just iterate over the array and check if it is obeying the condition or not, right? So just iterate over the array and check for any I if minimum of ai comma ai plus 1 is more than equal to mid or not. If it is, the answer is yes. Otherwise the answer is no, that your mid is not a possible answer. Otherwise your mid is a possible answer, right? So that is the first case, right? Now the second case, right? Else if your leftover operations is equal to 1, right? That means you only have one leftover operation. So you have your a1, a2, a3, so on up to n, right? And you will have some maximum element. You will have some element a max, right? Let's say you have your a max here, right? Then you can apply the operation on its adjacent element, right? And you can set it to 10 to the power 9. So now if you check minimum of 10 to the power 9 comma a max, you will get your value equal to a max, right? And you just need to check if your a max is greater than equal to mid or not, right? So basically in left row operation is equal to 1 case, you will apply your operation adjacent to the maximum element, right? And using this you will get the following relation. You will get the following relation, that your minimum of 10, 9, Amax is equal to Amax, and then you just need to check if your Amax is greater than equal to mid or not, right? So if your Amax is greater than equal to mid, the answer is yes, otherwise the answer is no, right? So that is the second case. Now the third case is else, when you have more than one operations, right? When you have more than one operations, left, that is simple enough. Then you can take any two elements, and set them to 10 the power 9, right? You can take any two adjacent elements and set them to 10 the power 9. So now if you check minimum of 10 the power 9, 10 the power 9, this will be 10 the power 9, which will obviously be more than equal to mid, right? Which will obviously be more than mid, right? So in this case you can directly return yes. So that is the case, right? So that are the three cases for the second condition, and you can like just use binary search in the following way and you will get your answer, right? So I will summarize this once again so you guys can get it. So we got our formula, diameter as equal to maximum of minimum over all I minimum. This is 2 times Amin, comma minimum of AL, comma AL plus 1, right? So that was your diameter. So we had two terms, the first term and the second term, right? So we ran a binary search, our maximum diameter. Let's say our current diameter is equal to mid. So now we have to check if our mid is a possible answer or not. So for that we will first maximize the first term, right? That is we will maximize Amin. So for that we will set all the terms where 2 times AI is less than mid. We will set AI is equal to 10 the power 9, right? That is for the first case, for the first term. And for the second term, there will be 3 cases when operations left are equal to 0. You can just check if the new formed array, has any index I where minimum of AI, comma AI plus 1 is greater than equal to mid. That is when your number of operations are 0, and if your number of operations are 1, just check if your maximum value in the array is greater than equal to mid. And if your number of operations are equal to 2 or greater than equal to 1, then you can just say your answer is yes, right? Because then you can just make any two adjacent element equal to 10 the power 9, and that will obviously give you an answer, right? So that is the solution. And if you guys want to see the code for this, here is the code. As you can see, here is my n and k, my number of terms and the number of operations. My low is equal to 1, high is equal to 1e9, right? So mid is equal to low plus high by 2. Then I will check, I will pass my array, the diameter that I want to check, and the number of operations. So my answer is equal to mid, low is equal to, so like if the diameter is possible, then my answer is equal to mid, and I will update my lower bound. And if the following diameter is not possible, then I will decrease my upper bound. I will decrease high equal to mid minus 1. So let's see my check function. So my check function, here is the first term. So I'm checking if my 2 times v of I is less than mid, then I will set my v of I is equal to 1e the power 9, right? And I will decrease the number of operations. And if my number of operations are less than 0, that means the number of terms where 2 times v of I is less than mid are more than the number of operations, right? That is, I don't have enough operations to obey the first term, right? In that case, I will just return false already, Otherwise, now I have to satisfy the second term. So to satisfy the second term, there are three cases like I told you, right? So if k is equal to 0, I will just iterate over the array and check if there is any index where minimum of v of I comma v of I minus 1 or plus 1 is greater than equal to mid. If there is, I will just return true. Otherwise, for k is equal to 1 case, I will check if my maximum element of the array is greater than equal to mid or not. Otherwise, I will just return 2. This is when the number of operations are more than 1. And if any of these conditions are not satisfied, I will just return false at the end, right? So that is the binary search part, and in the end you can just print out the answer and that will be it. I know the problem was a bit complicated, so if you guys have a doubt, feel free to join my Discord server and I will be more than happy to answer your guys' doubts there. So yeah, that was it for this video, and I will see you guys in the next one. Also, if you guys don't know, Continue Newton School is offering a full stack development course. The course is over 6 months long, and it is totally based on pay after placement model, and you don't have to pay anything. There is zero hidden fees, there is zero upfront fees, and they are granting you a minimum package of rupees 5 lakhs, and the average package is rupees 7 lakhs, and the highest package is over rupees 26 lakhs. So it is a very great opportunity. Also, all their mentors are from top MNCs like Google, Flipkart, Zomato, etc. Also, they will get you placed into the top MNCs as well, like Google, Flipkart, Zomato. So you can learn from the mentors that are working at those companies, and you can land a job at those companies yourselves. Also, you don't need to worry if you guys think कि यार मेरे को भी coding आती नहीं है, मैं भी fresher, मेरे को बिल्कुल नहीं आता है. The course is over 6 months long and they will teach you from scratch. So you can still sign up for this, and if you guys are looking for a career in the tech field, this is a very great head start that you should sign up for. And if you want to land a job, I highly vouch for this. And if you guys want to sign up, there will be a link down below and you can go and sign up from there. So yeah, be sure to sign up for this, and I will see you in the next video. Bye bye.